Hi, this video is about the mean and standard deviation binomial of a binomial random variable. Okay, so I'm just going to give you the formulas right now. The mean of the binomial, which also will be written like this, it's equal n times p, and the standard deviation, okay, which also could be written like this. The standard deviation of a binomial random variable is just np times 1 minus p. Okay, but how did we find this? Okay, so I'm not going to test you on this, but this is just some fun stuff to see how these formulas are derived. And this one here is basically you're going to see it's just kind of like common sense, because it's like on the last problem that we did. Like say you answered 4 questions and there was 4 possible answers. There was 4 possible answers, so the probability that you got one right was 0.25. So if you ask yourself, for every 4 questions that you take, for every 4 questions that you guess on, how many are you expected to get right? How many are we expected to get right? So that would be 1, right? So the mean in that case would be 4 times 0.25, which would be 1. So you can see as we do a lot of examples, this one's kind of common sense. But how did we get this? How do we get this NP? And how do we get this formula down here? So what happens is the binomial random variable is made up of Bernoulli trials. Okay, Bernoulli trials. I won't attempt to spell that because I'm not looking at it now. So what a Bernoulli trial is there's either a success or a failure. Okay, success or a failure. So I'm going to give the number 1 for a success and a 0 for a failure. Okay, and I'm going to set up a probability table for this. Okay, so it's a 1 if it's a success, and the probability is p. Okay, and it is a failure, we'll call it 1 minus p. Okay, we'll call this 1 minus p. So if I set up one Bernoulli trial, see the binomial is set up generally, there's a lot of different trials. These are all trials. That's trial 1, trial 2, trial 3, trial 4, trial 5, and so on, up to trial n. Okay? But what I'm looking at is I'm just looking at this one right here. I'm looking at the first one. This is either a success or a failure. If it's a success, then the probability of success is p. If it's a failure, then it's 1 minus p. So let's look at a probability model for a Bernoulli trial. So here it goes. You have 0, which is a failure, and you have 1, which is a success. Okay, so this is a probability model, and this is a success or a failure, and this is the probability of the trial. What's the probability? This is what's going to happen, and this is the probability. So what's the probability of a failure? The probability of a failure will always be 1 minus p. What's the probability of success? That's p. So let's find the expected value. Let's find the expected value of these successes and failures. Okay, so what's the expected value of each trial? So that would be 0 times 1 minus p plus 1 times p. So expected here is p. That's what we expect for one trial. Okay, so we can call this we could call this the first trial. That's x1. That's the expected value of x1. Okay, because this is the random variable x, success or failure. Okay, so that's p. So we know we have the binomial is made up of a lot of these trials. See, this is the first one. This is the second one. That's the second trial, which was the same as the first trial. This is the third one. This is the fourth one. So we could combine these random variables, and I could say the expected value for the total. Well, I could say the total. Let me do it this way. The total, I'm combining random variables. x1 plus x2 plus x3. These are all different trials. Every single trial. All the way up to xn. Okay? So if I said, what's the expected value of t, which is the total, that would be the expected value of x1 plus all the way up to xn. I'm combining random variables, which we had learned before. So this is going to be expected value of the total, which is the expected value of all the trials of every single trial, would be expected value of x1 plus the expected value of x2, which they're all the same, all the way up to the expected value of xn. Okay, so if you look at this one here is p, this one here is p also, and this one here is p. So the question is, how many trials did you run? We always run n trials. So we have n p's. We have n number of p's. So that's where we get the expected value of the random variable. Okay, and to the variance, I'm doing standard deviation, but to do the standard deviation, we always have to go through variance first. Okay, so to do the variance of x, it's going to be this. It's how far is this random variable from the mean. This is my mean. My mean is p. So it would be 0 minus p, and then I need to square that because I have to get rid of this negative, and then I multiply it to the probability of that happening. So that's the probability of that happening. Okay, then I sum how far is 1 from p. So that would be 1 minus p, and then I need to square this to get rid of the negative. There's 1 there, and then I turn around and multiply that down to p. So now I'm going to reduce this a little bit. I have 0 minus p, which is minus p squared, which is p squared, okay, times 1 minus p plus 1 minus p squared times p. So, and no, you're not going to be required to do this, but this is just kind of fun. So this is what I'm going to do. Now, I have two terms here. That's term 1, and this is term 2. I'm just doing algebra. So I have a like term with a p and a p squared. So I'm going to factor a p out. So I'm going to factor a p out. Okay. Now I have another like term. Here's a like term, and here's a like term. So I'm going to factor a 1 minus p out. Okay. And then what am I left with from the inside? Now, as my first term, I took this out, and I took 1p out, so I'm left with the p in there. Okay. For my second term, I took one of these out, so that's the first term, so it'll be plus. Now I'm on the second term. So out of this, look at the p came out. I factored the p out over here, and I factored one of these out, so I'm left with 1 here. So I'm left with the 1 minus p. Okay. So the variance is going to be, now okay, so let's look at this real quick. This is p plus 1 minus p. So if we combine our terms, this p will cancel out with that p. So here I'm just left with the variance being p 1 minus p. So the variance of one trial, not all the trials, of one Bernoulli trial is p1 minus p. So what's the standard deviation? What's the standard deviation of one trial? Would be the square root of p 1 minus p. So now I need to go after the variance of all my trials. Okay, so if you could see here, this would be all my trials. So I need to find, the standard deviation, but we never work in standard deviations. Okay, the standard deviation of t, which would be all my trials, all my x1 plus x2. So remember, that's the square root of all the variances. Okay, so change this into a variance. Here's the variance, so that would be p times 1 minus p. That's for the first one, plus, okay, that's for x1. Well, the second trial is the same as the first trial, so it's the same variance. It's p 1 minus p. That would be for the second trial, plus p 1 minus p for the third trial. And we're going to keep running this until I get to the nth trial. That's xn. Every trial is the same. So how many variances do we have? How many variances do we have? Okay. So the standard deviation of t, we have n of those. We have n. So it's going to be the square root of n of these guys. So it'd be n p 1 minus p. So that's how you get this. You're going to have to be comfortable. You're going to have to be able to comfortable using it. Okay, so whenever you get a problem, if it sounds like it's a binomial, okay, you're going to have to be able to be comfortable finding that. Or, yeah, just finding it, putting the np and 1 minus p in there. But this is how it's found, in case you're curious and you know, you enjoy this stuff. So thanks for watching.